Good day, everyone. Welcome to our class in Math 051, Engineering Calculus. Today, we are going to review the topic on functions. And since this topic is a very long topic, so we're going to divide it into several parts. And before we go to the details of our discussion, let us look at first the objectives of this lecture for today. So at the end of the period, you should be able to define and explain the concept of relations and functions, describe and discuss the difference between relations and functions, sketch and interpret the graphs of relations and functions, determine and describe the domain and range of relations and functions. Okay, so first we need to discuss relation. What is relation? So in our day-to-day life, we always heard this word relation. Like for example, at our home, we have relation between parents and children, relation between husband and wife. And during my time when I was still single, so I have also relation or relations, and then after that, my relation becomes X. So in relation, there's what we call X, like for example, ex-boyfriend, ex-girlfriend, and my wife was my last ex when I got married to her. Okay, so here in our discussion, the word relation is defined as a set of ordered pairs. A relation is defined as a set of ordered pairs. So the set of all first elements, so we know that we have ordered pairs, so the word pairs, so dalawa yan. So the set of all first elements, we call it abscissa. In the ordered pairs is called domain of the relation. And the set of all second elements, we call it ordinate, is called the range of the relation. For example, if you're given a relation that is expressed in this set notation, we have A contains an ordered pair of elements such as 1, 3, 2, 4, 3, 5, 4, 6, 5, 7. Okay, so this is an example of a relation that is expressed in set notation. And we also have another example here. We have set B that contains an ordered pairs of elements. We have 2, negative 2, 4, negative 1, 1, 0, 0, 1, 3, 2, 4, 3, 9. So this is our first ordered pair, second ordered pair, third ordered pair, fourth ordered pair, fifth ordered pair, and sixth ordered pair. So similar to this one, for set A we have the first ordered pair, second ordered pair, third ordered pair, fourth ordered pair, and fifth ordered pair. Now the domain and range is given by this expression or notation. We have DOA. It means that domain of set A, it contains elements 1, 2, 3, 4, 5. So this one here is when you speak of domain, as mentioned a while ago, domain is the first element of an ordered pair. So in this case, the element 1 here is the first element of the first ordered pair, and 2 here is the first element of the second ordered pair. Okay, and then 3 is the first element of the third ordered pair, and 4 is the first element of the fourth ordered pair, and lastly we have 5 is the first element of the fifth ordered pair. Now for the range, so we have RA, meaning range of set A. So we have elements 3, 4, 5, 6, 7. So these elements here are the second element of each ordered pair. So 3 is the second element of the first ordered pair. 4 is the second element of the second ordered pair. 5 is the second element of the third ordered pair. 6 is the second element of the fourth ordered pair. And 7 is the second element of the fifth ordered pair. Alright, so this is for set A, expressed in domain and range. Now for set B, so we have DOB. It means domain of set B. It contains elements such as -2, -1, 0, 1, 2, and 3. Alright, so again, the first element here, -2, this is the first element of the first ordered pair. -1 is the first element of the second ordered pair. 0 is the first element of the third ordered pair. And 1 here is the first element of the fourth ordered pair. 2 is the first element of the fifth ordered pair. And 3 is the first element of the sixth ordered pair. And for the range of B, it contains elements 0, 1, 4, 9. So if you count the number of elements here for the range of B, we have 1, 2, 3, 4, only 4 elements. But if you look at the ordered pairs of set B, it contains 1, 2, 3, 4, 5, 6. So there are 6 ordered pairs. But why is it that the elements here in the range of B contains only 4 elements? What do you think? So the reason behind is for the same element, we need to write them once. Right? For example, here in the second ordered pair, we have 1 here as the second element. And if you look at the fourth ordered pair, we also have 1 as the second element. So same number 1. So we need to write them just once. Okay, and if you also noticed here, the numbers are arranged in ascending order, starts from the lowest and ends at the highest. Okay, so we start with 0, then we have, this is the second element of this third ordered pair, then followed by 1. So this one and this one is just the same, so we have 1. And then if you look at the first ordered pair, the second element is 4, and the fifth ordered pair, the second element is also 4. So we need to write them once. So that's why we have here 4. And lastly, we have the second element of the sixth term, which is 9. Okay? So now to emphasize this, we have a colored version of the previous slide here. So we have here the first elements in set A. I colored it blue. Okay, and then the second as well as in set B. So the first elements were colored in blue, and for the second element they were colored red, to easily distinguish between this domain and range. So if you look at the domain at A, so all the blues here, you collect all the blue colored numbers, alright? And for the range of A, so you collect the red colored numbers. So these are the elements of the range at set B. Now for, set A. Now for set B, we have the domain. The domains colored blue also, the numbers. So you collect them all and you write it here. Okay, so these are the domains or the elements of domain of B. And for the range of B, so you just collect the colored red numbers. Again, the same number will be written once only. So we have 4 and 4, and then we have 1 and 1. So we just write them once. Alright, so I hope you got the idea on how to find the domain and range of a relation that is expressed in a set notation. Okay, next we have the ordered pairs that comprise a relation are frequently given in some way other than set notation. For example, so we'll take the same example as in the previous slide. So we have this set that contains all these ordered pair of elements. So the given relation may be presented in tabular form, like this one here below. So we have x and y here. So x, these are the x values, these are the abscissa, and y here, these are the values that corresponds to y. These are the ordinates. Okay, so for every value of x, you have a corresponding value for y. So for x equal to 1, you have y equal to 3. For x equal to 2, you have y equal to 4. For x equal to 3, y is 5. For x equal to 4, we have y equal to 6. For x equal to 5, y equal to 7. So this is the relation of x and y values. So there's a one-to-one correspondence. So the same example, the same relation can also be presented by a correspondence diagram, wherein one group is for the domain and another group of elements for the range, like in this diagram below. So we have here one group. It contains all the first elements of the ordered pairs that is in the set, and the second group contains all the elements, the second elements of the ordered pairs in the given set. So if you look at this, there is a one-to-one correspondence between these numbers. So 1 corresponds to 3, 2 corresponds to 4, 3 corresponds to 5, 4 corresponds to 6, and 5 corresponds to 7. So there's a one-to-one correspondence between these numbers, ordered pair. A relation can also be written as a formula, like for the same given example. So this can be written in this formula, that set A, or A is a set that contains an ordered pair of x and y such that x is an element of this 1, 2, 3, 4, 5, and y equals x plus 2. Okay, so this is a formula. So let us check now. If you look at these two numbers, if you subtract the second element by the first element, we've noticed that the difference is 2. Like for example, 3 minus 1 is 2, 4 minus 2 is 2, 5 minus 3 is 2, 6 minus 4 is 2, 7 minus 5 is 2. So there's a difference of 2. So that's why here in our formula we have y equal to x plus 2. So it means whatever is the value of x, you just add it by 2, then you will have the value for y. Like for example, if you have x equal to 1, when x equal to 1 plus 2, so you have 3 for y value. Now for x equal to 2, So your y value is simply x plus 2 or 2 plus 2. So we have 4. Alright? And if your x is 3, so your x is 3, so 3 plus 2, so you have 5. The value for y is 5. And when x equal to 4, 4 plus 2, 6. Then you have x equal to 5, so 5 plus 2, so we have 7. So this is a relation that is expressed or written in or written as a formula. Okay? Alright, so for the next part, we have the ordered pairs that comprise a relation are frequently given in some way other than set notation. So we can also express other than those way of expressing. There's another way like this one. Now we can express the relation or illustrate a relation by a graph or in terms of a graph like this one. So you have noticed that in this coordinates, Cartesian coordinates, we have points here. Okay, so the points, each point here is composed of x and y components or ordered pairs. So first you have to label this one. So let's consider this as 1 unit from 0. This is our 0 here. Okay, and then this is 1. This is 1 unit. This is another 1 unit. So 1 plus 1, so 2. So we have 3. Then we have 4. And this part here is 5. Then we have 6. Then we have 7. So this is for our x-axis. Okay, so this is our x-axis. And these are our x coordinates. And this is our y-axis, which is a function of x. It means that the value of y depends on the value of x. So that's why we have this expression y equal to f of x. So y is a function of x. It means that for every value of x, you have a corresponding value for y. So on this side, we also have to label this. This is our 1. This is our 2. This is our 3. This is our 4. This is our 5. This is our 6 and 7. Okay, so if you look at the first point here, so this point is composed of two components, the abscissa and the ordinate. So the first value, so that is in terms of x and y, ordered pair, right? Ordered pair. So each point shown in this graph, it's this point, like for this one. So this point here is composed of x and y values. So we have 1, 3. So 1 here is the distance from the y-axis towards that point. So it means 1 unit. That is the same from here to here. That is 1 unit. Okay, so this is also 1 unit, right? So that's why we have 1 as our first element of the ordered pair, and the distance from the x-axis towards that point, so yun yung y natin, y component. So if you count that, so we have 1, 2, 3. So that is equivalent to 3. So that's why we have here 1, 3. Okay, so this is the one that is given here. Alright, so similarly for this one, you just do the same. So when you have 2, 4, it means 2 is the distance from the y-axis towards that point. It means galing dito that is 2 units. Okay, then 4 is the distance from the x-axis towards that point. Okay, so that's why this point is composed of 2 and 4. Okay, that's 2 and 4. And so on and so forth. And we know if we connect all these points, we will form a straight line. Okay, so I hope you understand that one. So this is what is meant by a relation can be illustrated by a graph. Okay, next. A function is a special type of a relation such that each element in the domain corresponds to exactly one element in the range. Now, a function, a special type of a relation such that each element in the domain, meaning the first element, corresponds to exactly one element in the range. For every value of x, there is one and only one value for y. Okay, so for every value of x, there's only one value for y. Now for every value of x, there is one and only one value for y. Is it clear? So a function is a relation in which no two ordered pairs have the same first element and distinct second element. So we have to remember this concept so that later on when we discuss a relation which is a function, you will apply this concept in that part of our discussion. For example, so we are given here different sets A, B, C, D. So if you look at A and B, so these are considered functions. So why? So there is a corresponding one-to-one correspondence. So we have 1 corresponds to 2. Now look at the pair. No? 1 corresponds to 2, 2 corresponds to 4, 3 corresponds to 6, 4 corresponds to 8, 5 corresponds to 10. So there's one-to-one correspondence between this first and second element. We have negative 2 corresponds to 2, negative 1 corresponds to 1, 0 corresponds to 0, 1 corresponds to 1, then 2 corresponds to 2, 3 corresponds to 3. So we can say that these are functions. On the other hand, C and D, if you look at them, we have 0, 0 corresponds to 0, 1 corresponds to 1, 1 corresponds to negative 1, 4 corresponds to 2, 4 corresponds to negative 2. So you've noticed here, we have the same first element. In these two ordered pairs, they have the same first element, that is 1 and 1. And here, the fourth and fifth element, they have the same first ordered. So that makes the relation not a function. And similarly to this set D, we have 0, 5, 1, 6, 1, negative 6, 2, 7, 2, negative 7. So we have here two ordered pairs which have the same first element. Like this second ordered pair, 1, 6, they have 1, negative 6. So they have the same value for the first element. And also, the fourth and fifth elements, we have 2, 7, 2, negative 7. So they have the same first elements. So this makes the relation not a function. Alright, so both C and D are not functions. Is it clear? In terms of equation, a relation is not a function if y is raised to an even exponent. Ano yung even exponent? We have 2, 4, 6, 8, 10, and so on and so forth. So those are even exponent. Or if y is inside the absolute value bars. Ano yung absolute value bars? Can you remember the topic in algebra or any mathematics where you can see numbers that is on its left and right side there's a line. So those lines are called absolute value bars. So if y is inside with that absolute value bars, so the relation is not a function. Okay, so remember these two things. Y should not have an even exponent, or y should not be inside the value bars. Otherwise, the relation is not a function. Okay, for example, so we have here a, b, c. We have set or relation here in set notation. We have set A contains an ordered pair of elements x and y such that y equal to x plus 6. Oh, sorry, they are expressed in terms of a formula. And B is also an element, a set that contains elements x and y, ordered pair of elements x and y such that y cubed equals x, absolute value of x plus 5, and C, also a set that contains an ordered pair of x and y such that x squared plus y equals 10. So these are functions. So y functions. So first let us examine the exponent of y. For set A, the exponent of y is just 1. So it's an odd, not even. And the second set B, y is, or y has an odd exponent which is 3. Okay, and for set C, so we have y here that is or that has an exponent that is 1, and none of these y's here are inside the absolute value bars. So therefore, we can say that they are functions. So that is how to examine now whether the relation is a function or not, if they are expressed in terms of a formula or in a set notation. But in this case, so this is how the relation is expressed in terms of the formula. Okay, so these three examples are considered functions. But the second two, or the fourth and the fifth examples, we have set D and set E here. So if you examine them, we have a term here that contains, or the y here that contains even exponent. Okay, so this makes the relation not a function. And also in set A, we have here y that is inside the absolute value vars. So therefore, these two sets D and E are not functions. Okay, so they are not functions. In terms of graphs or graph, the graph of a function can be intersected by a vertical line in at most one point. So there's another way also of telling whether the relation is a function or not. No, if they are expressed in graphs. So, like for example, you're given a set or a function that is in, for example, expressed in an equation, and you tabulate and then graph them. So after your graph, you just draw a vertical line and try to see if that vertical line hits only at one point of that graph. If it happens, then we can say that that's a function. Like for example, if you have these two graphs here, we have a line and we have a parabola. Parabola opens up and we have a slanted line. Okay, so what we're going to do is just draw a vertical line. Just draw a vertical line like this. So if you draw this line and see that the line intersect only at one point, at this point here, so we can say that this is a function. This line is a function. Also, if you draw this line it hits only or intersect only at this point. Or if you draw a vertical line here, so it hits only or intersect only at this point. So we can say that this line is a function, or this relation is a function. So the relation that is expressed in terms of graph, so by using this vertical line test, so we conclude that this is a function. And similarly for the parabola, if you draw a vertical line, okay, so this vertical line hits or intersect at just one point of the curve or the graph. If you draw that line, or if you draw this line, so same, it all only intersect at this point. Or if you draw this line, so all throughout, no, when you draw the vertical line, it will touch or intersect or hit only at a single point in the curve. So we can say that this relation that is expressed in terms of graphs are functions. But a parabola that opens to the right or circle is not a function. Even the parabola opens to the left. But here it says that but a parabola that opens to the right or a circle is not a function, since a vertical line will intersect these graphs at 2 points. Now, for example, if you have this parabola that opens to the right, and now if you are going to draw a vertical line, so what will happen? So the vertical line will hit or intersect at 2 points in the parabola. So it hits here or intersect at this point, and it intersect at this point. So, or if you draw this line, same, it will hit or intersect at 2 points in the curve. Okay, so we can say that this is not a function. This relation is not a function. Similarly with the circle, see, when you draw the vertical line, it will also hit 2 points on the curve. Okay, sorry, that's not included, only this one and this one here. So the line, the vertical line, hits or intersect at 2 points in the circle. So these are not functions. Now, to determine if an expression is a function, so we have to derive the expression for y and analyze if any value of x will have exactly one value of y. So in short, it says that if we are going to express y in terms of x, if we found out that for every value of x there's only one value for y, then we can say that the relation is a function. For example, if you're given, say, number 1, we have x plus y squared equal to 4. So to find out whether this is a function or not, so we just solve for y in terms of x. So we have to transpose it to the other side. So we will have, okay, I will write it here. So we have on the left side, what is left is y squared. And on the right side, we have 4. Okay, so we have 4. Then when you transpose x to the right side, it becomes negative. So we have 4 minus x. Now to solve for y, we have to take square root on both sides. So when you take square root of y squared, we have y. And then on the right side, you have two values. Okay, you have plus and minus. Okay, so take the square root of the terms on the right side. So square root of 4 minus x. Okay, so in this case, we have two values for y, for every value of x. So therefore, we can say that this is not a function. Alright, so this is not a function. Second example, if you have y plus x squared equal to 5. So again, if we are going to solve for y in terms of x, so we have to transpose this to other side. So therefore, we have y equals 5 minus x squared. So we have only one value for y for every value of x. Okay, so for example, you have x equal to 2. So 2 squared, so 4. So 5 minus 4 equals 1. So you have only one value for y for every value of x. So therefore, this is a function. Now, for the third example, we have x times y squared equal to 1. So to solve for y in terms of x, we need to, in this case, tanggalin natin yung kasama ni y squared. So the only way to do that is we have to divide both sides by x, right? So when you divide this by x, what is left is y squared, right? And then on the right side, para mabalance, equal pa rin siya, we can still use the symbol equals. So what we did in the left side, we also do the same on the right side. So we have 1, we also have to divide it by x. Okay? Now, just by looking at the exponent of the y here, we can tell that this is not a function. Alright? Or you can solve for y in terms of x. Okay, so to solve y in terms of x, we take square root on both sides. So when you take square root of y squared, so we have only y. But on the right side, so when you take square root, you have two values on the right side. You have plus and minus. Okay, so plus and minus the square root of 1 over x. Okay, so this makes the relation not a function. So this is not a function. Okay, so in our examples, 3 examples, we have 2 relations here that are not functions. Number 1 and number 3. Alright, so I hope it's clear to you, class. And next is, we have what we call functional notation. So if this letter f is a function having as its own domain the variable x and its range the variable y, then the symbol f of x, so this symbol read as f of x, or you can read it as f at x, so denotes the particular value of y that corresponds to the value of x. For example, if you have a relation that is expressed in this formula, we have f is a set that contains an ordered pairs x and y such that y equal to 2x plus 3, then using this concept above, we can express this as f of x equal to 2x plus 3. Okay, so that says that on the left side, that is dependent on, that is the y variable. So y equal to f of x, meaning ang y natin is a function of x, meaning whatever is the value of x, you have a corresponding value for y. And that statement can be written as function of x is equal to 2x plus 3. Okay, so in other words, for every value of x, you have a corresponding value that is on the right side, which is, we called it y. And we express this as f of x. And y natin is a function of x. Okay, in other words, yung left side, value on the left side, dependent siya sa value ng x, which is in the right side. So, yan ang ibig sabihin nito. So, function of x, on the left side, we have an equation here. We have an equal sign. We have the left and the right side. On the left side, we have f of x. So, ang value dito sa left side, magdepende sa value sa right side, which is the value of x. So, yan ang ibig sabihin nito. F of x, or f at x, equal to 2x plus 3. So, this is an example of functional notation. So, from this notation, we express this into this form. Much simpler form. Okay. For example, if you have this expression g formula, no? G is a set that contains an ordered pairs of x and y such that y equals square root of x minus 5. So, ang G daw natin magdepende sa value ng x. So, we have function of x and y, where y depends on the value of x. So, this can be written as g of x equal to square root of x minus 5. So, ito yung expression. We transform this notation into this form for simplicity. If a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value of f of x is a real number. So we need to exclude from a function's domain real numbers that cause division by 0. And we also have to exclude from a function's domain real number or real numbers that result in a square root of a negative number. Okay, so you just remember these two phrase here, division by 0. We need to avoid it, or avoid numbers that can cause this division by 0, or a number that can result a square root of a negative number. So just remember these two concepts here. We will use that in our coming examples. So these are the principles that we're going to apply when we look or find the function's domain. For example, so find the function domain from this given function, f of x equal to 1 divided by x minus 5. Okay, so here we have a fractional expression. So as mentioned in the previous slide, the concept that we need to look at the number that can cause the division, meaning the division by 0, to avoid the division of 0 to happen. So we look at that number. So what value of x to make the divisor equal to 0? So to look for that, we have to equate this x minus 5 here. So x minus 5, para malaman natin ano yung number na makakos ng division to 0. So we have to equate this to 0. So x minus 5 equal to 0. So to solve for x, we need to add both sides by 5, or you just, if you add this by 5, this becomes x. Ma-0 na tong minus 5 and plus 5. On the other side, we have 5. Or you simply transpose this to other side and change the sign. So this becomes 0 plus 5, so that is 5. So therefore, we have x equal to 5. So this is the number that can cause division by 0. So that is excluded. We have to exclude that in the domain. Okay? So because division by 0 is undefined and not a real number, so the denominator x minus 5 cannot be 0. So therefore, the domain are all real numbers, or we call it R, except 5. And if you look at this in the number line system, okay, so we have here positive infinity, numbers approaching positive infinity to the right, and we have here numbers approaching negative infinity to the left, so assuming this is our 0. Okay, so we have here, we've solved the value of x, that is 5. So assuming we have 1, okay, this is 1, 2, we have 3, we have 4, and we have 5. So our 5 is located here, referred from 0. That's a neutral point. Okay, so x equal to 5 is excluded. So the domain is all real numbers except 5. Or we can write it in this manner. Domain is negative infinity, 5. And you have the symbol u here. Then 5, positive infinity. So what does it mean? So it means that, so this parenthesis means excluded yung infinity and excluded yung 5. Right? So on the left side we have this. So it means this interval here. Okay, this interval. Okay, so this is negative infinity and we have 5. So ibig sabihin yan, this is within this interval. And the other one is this one. So the interval here, which is 5, right, and positive infinity. Okay, so the interval 5 positive infinity. So we have to combine them. So we have to union them. Okay, so that's why we have here this interval in union with this interval. So ibig sabihin nito na all real numbers except 5. So lahat ng number dito are domains, are the domains of this function except number 5, this number here, which is 5. So that is what is meant by this expression or notation. Alright, so that's an example of finding a function's domain. Next example, finding a function's domain. So we have a given function here that is in radical form. So function of x or g sub x equal to the square root of x minus 7. So ano yung condition kanina sinabi? So the first one is avoid dividing by 0. Okay, so we have that example already. And the second one is avoid a negative radicand. Radicand means the values or the expression that is inside the radical form. So ito yung radical form. Okay? Ay yung inside nito ng radical form, ito yung sinasabing or tinatawag na radicand. So we have to avoid a negative radicand. So to find the values of x that will avoid us having a negative radicand, then we have to equate this, or we have to express something like this. X minus 7, that is the radicand. Alright, so in order to have a function defined, then it should be greater than or equal to 0. Alright, it should be greater than or equal to 0. If it is equal to 0, when the radicand here is equal to 0, so when will that happen? When x equal to 7, so 7 minus 7 equal to 0. Square root of 0, that is still 0. So we can define our function, g sub x. But if this is negative, for example, if x is equal to 6, so 6 minus 7, so that is negative 1. So what is the square root of negative 1? Okay, so that's undefined. We cannot define the value. So to avoid that, we have to solve for x here using this inequalities. So x minus 7 should be greater than or equal to 0. Okay, is that clear? You have to solve for x here. Okay, so how to do that? So you can add both sides by 7, or you just transpose this negative 7 to the other side. So therefore, we have x should be greater than or equal to 0 plus 7, so that is still 7. Okay, so our x must be 7, must be equal to 7 or greater than 7 in order for us to determine the functions here. Otherwise, this will be undefined. Okay? So, the expression under the square root must be non-negative. So, kailangan positive siya palagi. So, we have to solve the inequality x minus 7 greater than or equal to 0, which give us greater than or equal to 7, this one. Okay, so that's all for now. We'll end this review at this point, and in our next video, we'll continue the review of other types of functions. Thank you very much, and have a nice day to all of you and to all of us.